we are back. Give it a moment for people to join. I've noticed that whenever you join a stream right away, it kind of has a little bit of stuttering. So I'm trying to uh, massage that back out. Uh, I have thought about looking into how to like redo the live like at a certain time so it's exactly the same every day. I don't know. That seems a little wooden or like not as lively. I kind of like sitting in front of the camera for a few minutes, talking. Uh, Breaks up the monotony of my day. Uh, think I might go get the kitchen scissors and go mow the lawn. That's a that's a joke because that would take for fucking ever, and that's the the Electrical Training Alliance has been posting about how different instructors around the country are doing their classes, and I think, and obviously a very arrogant person. Uh, I think I'm doing the best because everybody else is like doing like Zoom, and that seems awful. If like all of you had to get good internet connections and like have video, like at this point it puts everything on me, and y'all just show up. That's it. That's good. I don't mind having it all be on me. And, a lot of times most of y'all show up. Alright, let's get this party started. Uh, when two batteries are connected as a series additive power source, they produce voltage that is less than either of the batteries connected by itself. So, that's absolutely false, and you all figured that out. That's good. Good job. Good job, you guys that took this. Alright. In a series circuit, the total or sum of all the voltages dropped across all of the circuit components is equal to the source voltage. This is titled Kirchhoff's law, or this is a paraphrasing of Kirchhoff's law. If you open your code book, not your code book, your DC theory book, I had that. Where did I put it? Oh, there it is. Again, DC theory book. There's such a glare. Alright. It's Y'all know what book it is. The DC theory book. You can look that up and read about it. You can Google Khan Academy has some great videos. Uh, Khan Academy has some great videos on Kirchhoff's law. I usually play them in class. I'm not going to do that in here though because they're on YouTube and you're already here. So just go find the Khan Academy videos. I should link those in the description. I'll try and find them. They were up a minute ago. As current increases in a series circuit, the voltage dropped across each load in that circuit will... Excuse me, that was a burp. Ugh. As current increases in a series circuit, the voltage dropped across each load in that circuit will increase. So, looking at your formula page, if we increased, like we have these numbers, And we did something, we don't know what voltage is anymore because we've changed things. Current, let's make it 1.5 amps. Well, if current's 1.5 amps, then we know the voltage 60 times 1.5 is 90 volts. So if you increase amperage in a circuit, voltage increases. In a circuit with two resistors in series, the voltage dropped across the resistor with the larger resistance value will be less than the voltage dropped across the resistor with less resistance. False. Yes, the larger resistor will have more voltage dropped. And you can see that if we had, so 1.5 amps, 1.5 amps. And let's say we had 45 ohms and 15 ohms. And I haven't drawn the circuit, bear with me. I'm just working the chart. We'll look at some circuits here in a minute. We have some good circuits drawn. But just mathematically, 45 times 1.5 gives you... oh, I don't know. Before I make myself look silly. Oh, that was 105. Hang on. Use the keyboard, Luke. 67.5. And then 22.5. Those are volts. Everything's marked. Okay, and then if you added these together, you would get 90 because the component voltages add together to be your total. All right, now we have a drawing. So let's pull up image pictures. We are looking at the one with the two power sources open with paint. Let's resize this by 3. And let's give ourselves some drawing space. Alright, so here is our circuit. It has, I'm going to jump to a new color. It has two batteries. The current is flowing in the same direction through. So those batteries add together, giving us an E total. That is another arrow. Don't need an arrow, need a pencil. We have an E total of 12 volts. We're going to throw I total there and R total there. Oh, the question was just what is E total, isn't it? Calculate the voltage that would be applied to the circuit connected to power sources as shown. It's 12 volts. That's all we needed. I don't know how you could have gotten to 36 or 5. Yeah, there's no way. Y'all are just throwing out random ass numbers. Alright, this question, That one deserves a... There it is. Let's open with paint. Alright, let's grab... Let's make red our color. Alright, so first thing you're going to do is determine the direction of flow through all of the... or the direction the batteries are sending. One thing to be sure is that this is a racetrack. It goes in a loop. So even though the arrow on this battery and this battery are going in the same direction, the current flow is actually going in the opposite direction. Because if a car was going this way along this racetrack, clockwise, this car will run into it because it's going counterclockwise. This particular battery is sending a charge counterclockwise, and this battery is, or no, this is clockwise. This one is counterclockwise. I should really stay away from saying clockwise and counterclockwise because I keep saying it backwards. Okay. So we've got our arrows. So what we're going to do is name one of them. It does not matter. We just have to name one of them as the correct direction, as positive. I'm going to say counterclockwise is positive. So this battery, oh damn, they changed my marker size. That battery is positive. This one is going clockwise, so that's negative. This one is counterclockwise, so we're going to call that positive. And this one is going clockwise, so that's negative. So all we're going to do now is start and throw all the numbers. So we have plus 30 plus 6, then minus 9 minus 9. Plug that into your calculator, you get 18 volts. All this took was paying attention and going step by step through the problem. All right. No way you could have gotten 480. 54 maybe if you added everything up. 18 is the correct answer. It looks like 54 must have been if you added it all up. 36 if you just added the two of them, but didn't subtract the others. So there's issues here. Yeah. Alright, let's get that picture brought up. What's it asking? Let's find what it's asking. Oh, is that it? Open with paint. That looks to be it. Is it? It definitely is. Okay, looks like I worked this and saved my work. I'm trying to be proactive or something. Given the circuit parameters shown, solve for the voltage drop on R1. So? Oh, it looks like I used this for something else, and then... Oh. Select. Alright. So now that we have our chart made up, we have two components, and Let's find... No, black is not used anywhere, so we'll use black. We have only 2 different resistors, so we only made 2 rows. And it looks like we have both these batteries are additive, so we have 12 volts total. That is not a pin. I should make a shirt, put it up in a merch store. That is not a pin. And then, let people's imaginations go for what that means. Alright, R1 is 250 ohms. R2 is 10 ohms. So now we can basically ignore the drawing because we've got our chart made. So the first step is look to see if you have 2 things on any of the rows. And we currently do not. We don't have 2 things on any of the rows. So we're going to look at the columns. So rows are horizontal, columns are vertical. We're going to look at the columns, see if there's anything we can combine together in the columns. And luckily, we have 2 resistors that will give us 260 ohms. Because 250 plus 10, pretty simple. Now, we're going to go back to the first step. Do we have 2 things on a row? Yes, we do, up at the top. We have 12 volts. We're going to divide that by 260 because of Ohm's law. 0.046. So that's 0.046 amps. So 0.046 amps and 0.046 amps. Alright, so now we have 2 things on a lot of the rows, and we can go down each row and do our multiplication. So 250 times 0.046, 11.5. And then 10 times 0.046, you don't need a calculator for that. That gives you 0.46. If you add these together, it gives you 11.46 or 11.96, which is really close to 12. And that's because we rounded. This was a whole long number. 0.046, 153846, 153846. Oh, it's repeating. But you don't need all the number, because that gets you really close to what you were looking for. Alright. Find the unknown value V2. So, you have 12 volts total in this circuit, and I'm not going to draw this one out. It's really simple. You have 12 volts total. You have one component that's 3 volts, one component that's 5 volts. And then a third component that is, you don't know. So 5 and 3 is 8. You're trying to get to 12. You're only missing 4. And it looks like maybe somebody didn't understand the question. But you would have had to go a long ways. And then unknown value V2 can't be an ohms rating. So I don't know, maybe one of these other ones was 80. It would have had to been, let's see, if this was 4. No, this can't be 80. I don't know, nothing's 80. Somebody did the math wrong. Okay, now we're to power. Power delivered in a DC circuit is the measure of the amount of work done by the circuit per unit of time. Yeah, that's just what the power measurement is. It's how much power the circuit is putting out. The sum of the power dissipated by each resistor in a series circuit is equal to the total power. So any of these. Let's do this one. Sound like somebody just banged on my window. But there's nobody out there. I hope. So if you had found powers, let's say it's 3 and you have 2 and 1. This has nothing to do with this over here at all. The sum, if you add power 1 and power 2, you get 3. That's your total power. Let's see. If you put more power to a resistor than it's rated to handle, it could be damaged. If you put drastically more, it's going to be damaged. Some resistors can take a little bit more power than they're rated for, but it's not like that's not permission to go all out on a resistor. Total power requirement is series circuit is the sum of individual powers. Yeah, we talked about that. All right. Find the total power dissipated in this circuit. So you have 36 volts and 72 ohms. This is a good one to talk about. Let's find that picture right here. All right. So let's make. There's only 2 components. We don't need to make more rows than we need. Than that, we have an R total of 72 ohms. We have an I total. We don't know. We have an E total of 36 volts. And we do not know power total. There's 2 ways we could do this. We could find I and then multiply I times E to get P. Or, and let me just show my work. We could do I equals E divided by R. So 36, that's an E. Hang on. That's another E. Hang on, I'll learn my numbers in a minute. 36 over 72 is going to be, I want to say that's 0.5. So now we know I total is 0.5 amps. And then 0.5 amps times 36 volts. That's a 4. I'll learn my letters one day too. I've been working on them. That's why I'm using this. I'm trying to learn a skill during this quarantine, and it's the numbers and the letters. All right, and 36 times 0.5 is, I can't write today, 18 watts. The other way you could do it is P equals E squared over R. So 36 squared divided by 72. I would need a calculator to do this, but I've already done it. It's 18 watts. That's another way that you can do it. And it does it all in one step. You just have to remember another formula. And that's my issue with it. So a handful of people got 18. 2592. Some people are talking together about their wrong answers. Let's see who it is. I don't think Carrie and Landon are talking together. I don't know how y'all got that. Ah, there it is. You just multiply the numbers together. That doesn't give it to you. What would be the minimum wattage rating? So what is the, basically this is asking, what is the wattage of resistor R2? We got one more question. I'm going to skip this one in favor of, ooh, this is a good one though. Okay, I'm going to work this one quickly so we can get to the next quiz. Let's see. Okay, let's open up that. I'm going to have so many open with. There it is. So many paint windows open. Let's give me some more width. Yeah, there we go. Where's my marker? Oh, there we are. Alright, so we have three values. So we got R total, R1, and R2. That's 27 ohms and 18 ohms. R1, we don't know yet. Yeah. We have I total. Then we don't know I1 or I2. They're all going to be the same whenever we find them. E total is 180 volts. And then P1 and P2. So, first up, we need to find what 27 plus 18 is. 45. Next, we need to find current by dividing 180 by 45. Once you have divided 180 by 45, you get 4 amps. And now you have 4 amps all the way down. And now you can multiply on out. 36. This is going to be 18 times 4 is 72 volts. And that will leave this at 108 volts. Multiplying 27 by 4 will give you 108. What I did to do that quickly was whenever I did 18, I just happened to know 18 times 2 is 36. 36 times 2 is 72, so that's 18 times 4 is 72. 180 minus 72 gave me 108. Because if I know what one of them is, the other one has to be whatever's remaining. Alright, so now that we've got all that, my math isn't as easy. Well, we're looking for R1. So now we can find all our powers. 180 times 4 is going to be 720 watts. Didn't give myself quite enough room. If I have a cheat, I can just bloop. Alright, 720 watts. 108 times 4, 8 times 4 is 32, so that will be 432 watts. And then 72 times 4. Oh, that's easy. 2 times 4 is 8. 7 times 4 is 28. so 288 watts. If you add these together, 8 and 2 is 0. 8, 9, 10, 11, 12. 4, 5, 6, 7. 720 watts. So these two add together to give you your 720 watts. So you've checked out. So what is the question in the first place? I recommend doing the whole question, the whole circuit every time they ask, just because you get that practice. So what is the minimum wattage rating for resistor R2? And that's going to be not 3420, 288. One person got it. Let's see who that is. Daniel Justice. Good job, Daniel. Damn, Daniel. Then finally, this one. This is a unique question. I'm a fan of it. I'm going to go through it relatively quickly so we can move on. But it hems on, they tell you what the voltage and wattage rating of this one component is, and you have to infer the missing parts. So R1, R total, R1, and the question is asking what is R1, and this would be L1. L is the same as a resistor. We call it R2/L1. I total, I1, I2. Your goal is to get current. If you get any of the currents, you have all the currents, and that's going to be super helpful. Okay, so we have our players. We got 0.5 watts. We have 4 volts. And we have 9 volt. That's a 4. Nine volts. And we don't have anything else. So right now, you can find current right now. 0.5 divided by 4. That's what is that? 0.128. Make sure you don't do it backwards. That's 0.5 divided by 4. Sometimes 0.125. So that means that's 0.125 and 0.125 amps. So now we've got current, but we still need something else. And what I suggest to do, you have 9 volts total and 4 volts from here, so you know this has to be 5 volts. That's all you're missing. And now you can multiply across on all of these and get the rest of your pieces. 5, I say multiply, I meant divide, 0.125. And your answer here is 40 ohms. All right. I know I said we should work all of these all the way out, but we're running behind. All right, I'm going to finish this one, start the new one. Excuse me. Didn't bring water in here with me. All right. have fun with this new one. It's not very long, so we will be back shortly at 3:45. See you then.